So we're going to get started today with Łukasz Gebel. I think I'm pronouncing your name right at this point, Łukasz, but Łukasz is he is a software engineer at TomTom, and he enjoys distributed systems and machine learning. And he is also a passionate striker on the football pitch, who transforms into a bookworm at night. So I don't know what you've been reading, Łukasz, but maybe you'll talk about that today.
A lot of different things, really.
All right, so if you're ready, I'm going to let you take it away.
Sure, I'm ready. Let's start before I turn into a bookworm. Okay, I'm sharing my screen. Let me know when you see it.
We can see it.
Okay, so I'm ready to start the story. So, hello everyone. Let me start the story about the Stormtrooper way of processing streams. So, a long time ago in a galaxy far, far away, okay, actually it was in Poland, so not so far away, but still for the sake of story. Me and my team, we got a task to build a highly performant, highly available, and distributed system. So we do a serious research, investigation, design, and we decided to go with Apache Storm with this task. And that's how we became Stormtroopers. So Alexandra already gave me a good introduction and really pronounced my name really well. It's not easy if you're not a Polish native speaker. I will just add that I work for Location Navigation Services Department, and my team, we work on deploying and implementing systems that help you to dispatch the large fleet of cars, for example, taxis, in an optimal way so they can reach their destinations on time. But get back to Storm. So I will start with what is Apache Storm, and then go to processing model and show you a sample distributed application. And then I will share the things that I missed at the very beginning with my journey with Storm. I wish I didn't miss them. Okay, so briefly speaking, Apache Storm is a distributed real-time computation system. And it's described in the best way by these two features, so distributed and real-time. By distributed, we usually understand the system that has a couple of nodes that communicate through network, and they communicate to achieve a common goal. And in Apache Storm, we focus on distributing our tasks. So we want to build an application and distribute the parts of that application between different nodes. When it comes about real time, we usually think that real-time system has to finish their processing and get response before given deadline. Sometimes it's a soft deadline, sometimes it's a hard deadline, but in general, you must be fast. And Apache Storm was clocked against different benchmarks, and it was proved to have microseconds latencies and 1 million tuples processed per second. And you may be wondering what are tuples in Storm. So let's go to the processing model. So while explaining processing model, I will build an app that will recruit Stormtroopers and will dispatch them on different planets. That will be our idea. And I will try to find some spies inside Stormtroopers' army. So for your information, Stormtroopers are Imperial soldiers in Star Wars, and they are legendary for missing their targets. I don't know if they ever hit any rebel, and I will use this idea throughout my presentation and in my code. So get back to a tuple. So in Storm, tuple is a set name on fields and values, and it's simply a single chunk of our distributed data stream that we process. And tuple can be any serializable object. Serializable because we distribute our tuples among different nodes, so it goes through a network. Then we've got streams, and streams are unbounded sequence of tuples. In our case, we will have streams of Stormtroopers. Then we've got the first bigger component of our applications called spout. And spout is like a starting point of our pipeline. So spout can produce tuples, or it can pull data and wrap them in tuples from external resources like APIs, like databases, caches, whatever fits your use case. Then spouts can be reliable or not reliable. So when spout is reliable, it's aware of messages that it emits and if the messages are processed successfully or not. And for example, it is aware of and capable of retrying such messages. And not reliable spout just fire the tuples and forgets about them, and probably will use it in real time use cases when you don't really care about the responses if it takes too long. Next, we've got bolts, and bolts are tuple processors. So they get an input tuple, do some work, process a tuple, and they may produce its own tuples or just finish our whole processing pipeline, finish our application. Tuples, maybe you may think of tuples as of messages, and Storm provides the messaging guarantees level because they go through the network. So the first level is the best effort, and it means that Storm will just try its best to process your data, but there won't be any retries and you don't have guarantee that every tuple will be at least once processed. Then you've got at least once model, and at this level, you need to have a reliable spout that is capable of retrying failed tuples, but such tuples may be processed more than once. And finally, you can have exactly once level, and it's a fully stateful model. But here we need to ask someone from different universe for help. We need an Aquaman because he has a trident. And trident is an extension for Storm that supports this fully stateful model. And then you've got this guarantee that every tuple will be processed only once. However, you get this persistence under the hood, so the performance will be decreased in comparison to best effort and at least once model. And how these models are provided in Storm. So for every tuples, Storm builds tuple tree, and you can get acknowledge or face signal in your spout. So let's look at the example. Let's say that our spout emits a tuple and it goes to a bolt, the first bolt, and at this bolt, the tuple is, new tuple is produced and it goes for the third bolt for the further processing. And we already acknowledged that bolt number one processed the tuple, so it's acknowledged. Then Storm builds such a tree, and if this tuple in the first bolt is processed, it removes it from a tree. But there is a still tuple in the third bolt. So after processing it in the third bolt, it is acknowledged, and it is removed from a tree. When a tree is empty, our spout will get the acknowledged signal, and it can handle the successful processing or just log, for example, that it was processed successfully. On contrary, if our tuple is failed on any level, our spout immediately get a fail signal. But there is also a third option, because in distributed environment, for example, your node may disappear, like in cloud environments, or the network may have some problems. So sometimes you may not get acknowledge or fail signal at all. And here we've got the message timeout feature. So for your applications in Storm, you can set the message timeout. And after this timeout, your spout will get a fail signal if you didn't get the acknowledged or failed before. So it's like a backup. Okay, we called our distributed application in Storm world topologies. And topologies are sets of spouts and bolts, and formally speaking, they are directed acyclic graphs. Our topology that I will build will look like this. So we'll have the spout that produces stormtroopers. We've got bolt that dispatches stormtroopers to 3 different streams. And we will have 3 training mission bolts, like 3 planets for training mission. So let's look at the code. First of all, let's start with a spout. So I've got my recruitment spout. And to implement spout, I implemented the Storm interface called iReachSpout and implemented its methods. So the first constructor-like method is called open, and it happens when your spout lands on a distributed node before it starts processing and emitting tuples. So you simply get abstraction called output collector from Storm. It is used to emit tuples. Here I initialize the Storm Academy. So Stormtroopers Academy will just produce my Stormtroopers. And I also added an executor that will log the number of successful Stormtroopers because I don't want to log any Stormtroopers, as I expect there will be millions of them. So I will log them every 10 seconds. Then we've got the declare output fields method. And that's the part where we declare what our spout will emit. So in my case, our spout will declare Stormtrooper tuples. So the name of our field will be a Stormtrooper. And the crucial method, the next tuple, here we've got the Storm Academy that educates a Stormtrooper. So it's simply assign a academy grade. The best academy grade in Stormtrooper world is the miss the whole point. The lowest one is not mismatch. And we randomly choose the grade and the preferred planet because every Stormtrooper dreams about the preferred training planet. And that's how we get our data produced. And then we emit it for further processing. So I do output collector, emit, wrap my brand new Stormtrooper in new values, and also provide this tuple ID that will come back to me if the Stormtrooper will be processed correctly, successfully. So we've got this acknowledge method. And in this object, I can get the ID of Stormtrooper that I emitted in the next tuple. And I will increment successful Stormtroopers counters on acknowledge method. And in fail method, I will log that it is probably a spy because he didn't pass the training mission. We have also close activate and deactivate methods if we want to have more advanced control over our spouts remotely, but it's more advanced stuff. If you're interested, you can check it out on your own. And I will go for the first bolt. So our spout will emit tuples to training bolt, training dispatcher bolt. And to implement a bolt, I need to implement an iReach bolt interface. So here I have a prepare method, which is like this open method from spout. I also have this output collector for emitting tuples. And I've got a set of good students. So simply good students are Stormtroopers that got the grades missed the whole point or missed by a mile. And I've got the assign commission to assign them to training planets. Our declare output fields method, here I declare 3 streams because we've got these 3 planets to dispatch Stormtroopers. And for every planet, I create a stream called the planet name. And then they will also have this one field, the Stormtrooper field. And finally, we've got the execute method, which gets the input tuple. And from input tuple, I use get value by ID, provide this Stormtrooper field name, and I have my Stormtrooper that goes from spout. Then I assign a planet for a Stormtrooper. So if it was good student, it can go to preferred planet. If not, the planet is randomly chosen. And then I emit a tuple for training mission. So I provide a stream name, simply planet name in this case. I anchor my tuple because I don't want to make it acknowledge immediately after this bolt. We want to wait for the last bolt to process the whole tree. And then I also wrap my Stormtrooper into values and emit such tuple. Finally, I check that this tuple is acknowledged at this level. And the last bolt, it's a training mission bolt, the simplest one. So in prepare method, I only assign this output collector provided by the framework. I don't have output fields because that's the last bolt in my pipeline. And in an execute method, I also extract the Stormtrooper from a tuple and I run a complete mission. So here our Stormtroopers will try to miss its targets for 1000 times. And if they have enough number of misses, they pass the mission. So if they completed the mission, I acknowledge tuple and the whole processing is okay, successful. The other way, I fail a tuple because if Stormtrooper doesn't miss its targets, probably it's a spy, a rebel spy, and we will get the signal in spout. Then I've got my main method, And in the main method, I built my topology. So I use a topology builder provided by the framework, and I set a spout to our recruitment spout. I set a bolt. The first bolt will be a training dispatcher bolt, and it connects to our spout by shuffle grouping. It means that tuples from our spout will go randomly to all instances of training dispatcher bolt. We can have more than one instances to parallelize our processing. And finally, I've got 3 training mission bolt, one for each planet, so for Tatooine, for Hoth, and for Endor. And these bolts are connected to the training dispatcher bolt, so the second one, and they simply are connected to each of the streams from the second bolt. Finally, I create a topology. I create a config and set number of workers to 2. I will get back to workers in a moment. And I submit a topology to a cluster. And our distributed application should be distributed in our cluster and start working. Okay, so let me get back to presentation. Regarding our cluster, so we'll need to meet 3 guys. First is called Nimbus, and it's like a master node that distributes the work over a cluster. So it sends orders to start a topology, to stop it or kill it. Then we've got supervisor, and supervisors are nodes that simply do your work. So they get orders from Nimbuses and they run workers, and each worker is a single JVM. And on these JVMs, our spouts and bolts are working, and these are tasks. And every task is by default 1 thread. You can change it if you need different setup. And finally, we've got Zookeepers for cluster coordination. And when you are setting up Zookeepers, you need to follow up this formula. So 2n plus 1 instances. So the minimal highly available setup for Zookeepers is 3. In general, you would like to have at least 2 Nimbuses and 3 Zookeepers and at least 2 supervisors, because these are the nodes that do the work. So probably supervisors, you will have even more than 2. Okay, so let's run the code. So I already downloaded my Zookeeper and run it on a default port 2181. Then I downloaded the Apache Storm, and it provides the Storm binary. And you run your Nimbus by simply running Storm Nimbus. Then I've got a Storm Supervisor, Storm UI, and here we've got my application. Yep. So now if we want to start a Storm, sorry, I have to switch the sharing. Here I've got my application. Sorry for this short interruption. I didn't see the console. So I built the topology. So I've got this jar, and now I run storm jar and provide the path to my jar and its main class. And I am sending my topology to a cluster. It's already there. And I expect to get some logs in a moment. Let's check the Storm UI. Storm UI is like a simple management one. So topology should be visible here. Yes, it is. Okay. And logs are also here. And now we should see logs. So as you can see, we've got this number of successfully trained stormtroopers and some spies already. So for every spy, we've got a single log line, and for every 10 seconds, we get how many stormtroopers we get. And it is updated currently. For the couple of minutes running topology, we've got over 1 million of trained stormtroopers. So it works. Okay, let me get back to the presentation. So now I will share my experience, so dark side and light side of Storm. Let's start with the light side. So Storm is really easy to start. As you can see, you just need to implement spout bolts and download the tool, and you can test it even on your local laptop, which is not very distributed one. So the processing model is quite easy and flexible. So you can put the code you need inside the bolt, any logic that you need. So there are not many constraints really. It's very flexible. It easily integrates with other tools, databases. There are many examples over the internet, and even Storm provides some out-of-the-box integration with the most commonly used tools. It has really minimal performance overhead. Of course, it's useful to check it on your own for your own use cases, but it's really optimized, and performance is one of the key features of Apache Storm. And you get the distributed architecture out of the box. So you just need to set your Nimbuses, Supervisors, Zookeepers, put your applications, and you've got a distributed system. For dark sites, so you need to be aware that topologies are static. And it means that, for example, if you need more bolts of a given type or spouts while topology is running, you have two options. So you can run multiple topologies of the same type to scale up or scale down, or you can do something called rebalance. And when you do rebalance, topologies, some of its parts may be stopped for a moment, and then they will be reinitialized with the bigger number of instances. Next thing that is important, you need to know that when one task in your worker, for example, bolt, throws a runtime exception, the whole worker is down, and the components that are working on this worker are also down, and Storm is designed to fail fast, and it will be reinitiated very quickly, but still there may be this small pause. And you should be aware of serialization and network latency while designing your application. Because if you put too many small tasks, you will get a lot of times when you serialize your tuple, it goes through a network, then it is deserialized, and so on and so on. So you really should be careful while designing the bolts and spouts, so you don't get overhead because of your poor design rather than the Storm performance. Okay, summarizing talk, I showed you how to build a simple topology, showed you how to run them on a cluster. I know that laptop is not a very distributed one, but still it's a good simulation. And I showed the main pros and cons that I took from my experience. So now call to action for you. So if you are new to distributed systems, it's really nice tool to start with, and you can learn how to implement, design such systems using Storm and go deeper and deeper. If you're a more experienced user or advanced user, I really encourage you to benchmark Apache Storm. I think you should be really happy with its performance. And finally, if you'd like to play on a distributed cluster, you don't want to set up your own, and you are using Azure, you can check the HD Insight managed service, and it has Apache Storm cluster out of the box. Thank you very much for your attention. I hope to see you in October, and that's pretty much it. That's the bibliography. I put the code and presentation also on my Twitter. Now I'll be happy to answer your questions, and I'll get back so you can get links once more. Thank you very much.
Thank you, Łukasz. Do we have any questions that anybody wants to say live?
Yeah, feel free.
I have a question, Łukasz. So how do we handle unexpected situations? Like what if one of the cluster processes disappears or it becomes unhealthy?
Yeah, so basically speaking, when something goes wrong, you should have a minimum redundant setup. So as I said, you need at least 2 Nimbuses, and at least 3 Zookeepers, because in such setup, 1 Zookeeper or 1 Nimbus can go down. And when your application or part of application goes down, it will be recreated automatically by Storm. So the new worker will be recreated, and the components of your application that disappeared will be recreated on this new worker. However, you are responsible to make your application, your topology aware of this recreation and failures. So when it is recreated live and it fails fast, it should instantiate properly and be ready for such failures. Does it answer your question?
Yeah, it does. We have one from Luis. It says, can we control how Apache Storm distributes the tasks inside the cluster?
Okay, so you can choose different types, for example, of streaming. So for example, if you want to put tuples that should land always on the same bolt, you can use different type of streaming. So in my example, I use the shuffle streaming, the shuffle grouping. However, there is a direct grouping, or there is also something like hashing grouping. So it's like consistent hashing. So for example, you can hash your tuples by a field or by a whole tuple, and then your tuples will go straight to the component that you want them to go. There is also a feature of Storm that gives you the resource-aware scheduling. And it means that you, for example, may have nodes that are GPU optimized or CPU optimized, memory optimized. And then you can set up such a scheduler and say that, okay, these bolts should go to the GPU optimized nodes, and different bolts should go to a memory or CPU optimized nodes. So you can have a full control over it.